Hello, my name is Siri Vennela MANTRAVADI, and this is the video for the testing section of my computer science NEA, which is a solar system simulation. Before we get into the testing, we're going to look at the objectives and performance criteria for the system. First of all, we need to create a turtle object. We need to create an object using the turtle library on Python for the sun, the 8 main planets, and also the 5 main dwarf planets, which are all the objects included in my simulation. Then the size and color of each object needs to be set to be similar to what it actually is in real life. The celestial bodies and objects should be positioned correctly on the screen and should all be visible. Every planet and dwarf planet should be orbiting and actually moving around the sun, and a trail should be drawn behind every moving object to show their path around the sun. When the user clicks on an object, the program should halt, and only the object which has been clicked should be flashing. When the user clicks on the object, it should display its name as well as key facts about it. These are the numbered objectives that the testing is going to be based on. So here are the test cases for the testing that I'm going to be doing. And I'll fill out the evidence and the pass or fail as we go along. So the first test is to launch the application, which means we need to check that the program runs without any errors. As we can see, no error message showed up, and the program launched fine. So we can fill in that the evidence has been seen and the test was a pass. The second test is to load the application with the objects and to ensure that all the objects are loaded onto the screen and are all visible at the same time. Here, as you can see, the sun, 8 planets, and 5 dwarf planets, so in total 14 objects are visible on the screen all at once. So the evidence has been seen and the second test is a pass. For the third test, we need to check that the size of every object is as calculated, and this can be compared with the size listed in the size body variable in the code. So although we can't calculate based on these values, we can see that the sun is meant to be the largest object in the simulation, and Ceres, the dwarf planet, is meant to be the smallest. So let's check that that is still the case. The sun in the center is most definitely the largest object in the simulation, and Ceres, the little dwarf planet behind Mars, is definitely the smallest dwarf planet in simulation. And we can also see that Jupiter is roughly half the size of the sun. So the evidence for this test has been seen and it is a pass. For the fourth test, we need to show all the objects at their initial positions, and these are randomly generated coordinates. So for this test, I'm going to run the program twice, and for the second time, the initial positions of the moving objects should be different to what it was the first time. So let's run it first. So the sun will always be in the center, but let's pick a reference point. For example, Jupiter was approximately the parallel to the sun. So let's run it again and see if it's different this time. So this time Jupiter actually ended up on top of the sun. So this means that the initial positions are definitely randomly generated. The evidence has been seen and the test is a pass. The next test, we need to show that the planets and dwarf planets are actually moving and orbiting the sun. This can be shown by looking at the coordinates of the moving objects, and they should be changing as they move around the sun, and the line showing the orbital path should appear. We can see that over time, the objects are moving forwards in a circular motion, and a line showing their orbit is appearing behind them. So you can say the evidence for this test has been seen and it's a pass. Test number 6, we need to show that the trail line behind the moving objects as they orbit the sun, and this line should be the same color as the object itself, and it should appear behind the object as it moves around the sun. We'll let it go for a while just to see the circular path being drawn. But we can see that for all the objects, the line is the exact same color as the object itself. And we can also see that all the objects, for all the objects, the trail lines are moving in a circular direction to make a circle around the sun. So this test is also a pass. Now, this next test, we need to check that the user can actually click on the moving objects. So this means we have to, when we click on the object, the program should respond without too much delay to that mouse click. So if we click on Earth, for example, text shows up almost immediately. So, and click on another planet, Saturn, again, the text shows up pretty much immediately. So this test is also a pass. Test number 8, we need to show the object flashes when clicked and the rest of the program halts. So when the user clicks the object, it should disappear and reappear in approximately 2 seconds, which we'll verify a little bit later on. Whilst the rest of the objects are halted in their positions and do not move at all. So let's see if that's the case. Click on Mars, for example. And for this one, the planet didn't actually flash, but the text was displayed and the rest of the program was halted. But let's try another planet. So Neptune, again, it didn't flash, but the rest of the program was halted. One more time, let's pick a different one. So this time Jupiter did actually flash once and the rest of the program was halted. So let's see if this works for another planet. So Saturn, it didn't really work. This test um, is actually really a partial pass because it only worked for some of the planets. For the next test, when the object is clicked, we need to check that the program displays its name and key facts about the object. And the name and the key facts should all be in the same color as the object itself. And we need to check that the name is in a bigger font than the facts. So pick Mercury, for example. You can see that the text was the same color and the name was a bigger font size than the text. We'll see again with this one. Yeah. And we'll try again with Venus. Yeah, so we can see that the name was in a bigger font and they were both the same color as the object itself. In the next test, we need to time the duration of the halt and make sure it is equal for every object that is clicked. For this test, I'm going to use a stopwatch to time exactly how long the text appears for. I am limited for this test by my reaction time, so it will be slightly different for each object simply because of reaction time, but we are aiming for roughly 2 seconds pause. We'll see if that actually is the case. So I'm going to start the stopwatch when I click on the object and stop the stopwatch when the text disappears and the planet and the objects resume moving around the sun. So that was around 2 seconds, 55 milliseconds. Let's try another object. Yeah, this time it was 2 seconds and 40 milliseconds. So roughly around almost up to 3 seconds, the program halts and the text flashes for the user to read. So we can say that that is the same for all the planets, or sorry, for all the objects. So the test is a pass. The last test, we need to check that if the program, we need to check that the program does not terminate if too many objects are clicked. So for this test, we're going to click on 3 to 4 objects at the same time and see if the program crashes or terminates. So it's a successful test if it does not terminate, and we'll see what actually does happen if too many objects are clicked. How does the program deal with this? So as you could see for a couple of seconds there, I clicked on 3 different objects and the text overlapped, but the program is still running fine afterwards. We can try again to verify that. So yeah, the text on the right does overlap and the colors sort of merge together, making it really confusing to read and tell which text belongs to which planet. But the program itself does not terminate, and after the duration of each planet has been passed, the the objects continue orbiting around the sun. So this test is also clean, And we can say that the program does not terminate, but the text overlaps. So this test is a pass. These are all the test cases for the for my simulation, and they are all a pass. So that's the testing finished. Thank you.